Morning, Craig here. Right, now I've learnt something this morning. Hopefully, if you can see me, it's because I've set this stream up correctly this time. Now, earlier I actually recorded a 49-minute live stream, or at least so I thought I had. I did one yesterday as a test and it all seemed to work well, so I thought I'll go into OBS Studio, which is the streaming software I'm using. I'll hit stream and it should work. Now nothing's happened. Well, I spent 49 minutes talking about radio communications and I thought it was quite good actually. I also talked a bit about open source software and I thought, yes, I could get used to this live streaming, but it's not. When I look at my my channel, there's no live stream on there. Now I think where I've gone wrong here is that I needed to get the stream key from YouTube and enter it to start streaming. Now I assumed I could use the one from yesterday, but I don't think it works like that. So what I'm going to do, literally live on the stream, is I'm going to look at my own stream. And there I am. Yes, I am live. Yeah, so that's working. Right, well, yeah, what was I talking about earlier? I thought I could talk about it again. Well, let's change it slightly. There's a load of radio equipment behind me, radio communications equipment. But let's talk about the streaming setup I've got here first of all. So, the webcam is a really cheap £25 webcam I bought during lockdown. Now this streaming setup isn't my normal one. I normally have a gaming laptop that has a separate NVIDIA GPU in it, which I can use for hardware encoding, and a 4K webcam. I have a Blue Yeti microphone, 4K monitor, all the rest of it. Whereas this is the back bedroom, which consists of a £25 webcam, a monitor, though I'm going to buy a new one later I think, but at the moment I'm using this old monitor which I bought from the second-hand shop for a tenner. It's a flat screen, it's not a CRT one, it's a flat screen one, but I bought it probably 12 years ago and it was second-hand then. It works fine, but it's old. The computer is a second-hand i5 which I got off eBay, 6th generation. Now, the keyboard, it was new old stock that they chucked in the skip at the employer I used to work at because they were having a clear out. Same with the mouse, so it's a bit of a a recycled bit of kit here. So apart from the webcam, which was new, £25, everything is junk or second hand. As I say, I've got a sort of state-of-the-art, everything 4K, modern laptop, but I thought I'd have a go streaming on this because I wanted to put it in the back bedroom because it's quieter, because in the main room it's just noisier at that part of the house. So I'm just trying this out. Now we're using a lot of open source software. First of all, OBS Studio. Now, OBS Studio, let's see, if I drop that down there so you can see the screen come off this. Let's see my phone. Right. So we'll don't want that. Right, here we go. Right, OBS Studio. Let's just get my phone up so I can see what's happening with this live stream. make sure it's actually working. Get rid of that. Oh yeah, there I am. Now I can see it live. Right, OBS Studio, here we go. So, Open Broadcaster software. Now, as it says here, Open Broadcaster software is free and open source software for video recording and live streaming. Stream to Twitch, YouTube and many other providers, or record your own videos of high quality H.264/AAC encoding. Pardon me. Right, now we'll click on that. Look, just in case you haven't come across OBS Studio before. Now, why is this taking so long? That's interesting. Come on. Should be running at hundreds of megabits a second, this broadband. I'm not quite sure why OBS Studio won't open. Let's try and open something else just as a try Wikipedia. Does that work? Well, Wikipedia's working, so why is OBS Studio not open? I don't know. Right, as you can see here, you can have there's a Windows version, there's a Mac version, and there's a Linux version. Now, I'm using a Linux version. I'm just going to where's my OBS Studio gone? That's better. I can see myself again. I've just realised you wouldn't actually seen any of that because I've got to slide the thing across an OBS Studio to minimise myself. Let's go at it again. Here we go. Open Broadcaster software. OBS. Open Broadcaster software is a free and open source software for video recording and live streaming. Stream to Twitch, YouTube and many other providers, or record your own videos with high quality H.264/AAC encoding. And it's available, as it says here, as I've already said, for Windows, Mac or Linux. Now, what I'm using here on my recycled PC, which did actually come with Windows 10, but I got rid of it. I'm using Ubuntu Studio. Now, Ubuntu Studio, let's show you what that is. Ubuntu Studio. It's a distribution of Linux, and it's a version of Ubuntu. So let's just read what they say. Ubuntu Studio, a free and open operating system for creative something or others. Right, Ubuntu, let's just click on it, see what gives more of a description. A content creation studio on your computer, and it's free. Yeah, so the latest version is 24.04.3 LTS. Now LTS stands for long-term support. Now the Noble Numbat, they always give them weird names. Like Windows, you get Windows 10, Windows 11, or you get Mac. I'm not sure what we're up to now, but Mac 10.4 long ago, which I had on my old Apple Power Mac. That is the number, and then they move to 10.5. But whereas Ubuntu, they give them names like Noble Numbat. Don't know where they get these names from, but they're more interesting than just a number. So the LTS stands for long-term support. So it's supported till April 2027. So if you download that, it will be supported till then. And then you can upgrade. I'd say it's free, which is good, and yeah, it's good. Right. Okay. So why Ubuntu Studio? So with Ubuntu Studio, then, which remember is the operating system that I'm using on this second-hand eBay PC, which is an old Intel i5 with about 8 GB of RAM. So audio, you can record, mix and master. So whether you're aiming for whether your aim is recording, mixing, mastering, live processing or even coding, there are a variety of tools for you. With a full suite of audio applications, Ubuntu Studio can support you with these kind of tasks and many more. Now, if you're interested, rather than reading the whole website out, you can click on ubuntustudio.org. So graphics, yeah, and you get applications such as GIMP, Inkscape, and Blender, which come with it. And video, you can edit home movies, you can yeah, full HD films. I don't know if it supports 4K with the software that it comes with, but you can download free software for Linux that will support 4K. I've not tried. I mean, this computer's not. It's going to be pushing it a bit to be doing 4K on it. I'll use my Windows laptop with 32 gig of RAM and 2 terabyte hard drive and separate NVIDIA GPU, all the rest of it. I'll use that for serious video editing. But for light video editing in HD, this is great. You do photography. So that's Ubuntu Studio, and that is the operating system. So features, audio, graphics, photography. And that's what I'm running. So that is the setup we've got here. Connection is timed out, don't like OBS. Temporary unavailable. Now it could be that I've got the VPN switched on. Well, it just comes on automatically. I use this as a work computer and just basically connected to the last server and not much else. And I've got a permanent VPN connection on it at the moment for no particular reason, but that's VPN, by the way, virtual private network, but I'll talk about that another time. Are we still on? Live stream. Oh yeah, we are. Right. Okay, let's try it again. I don't know why it's not loading up. Very strange. Right. I did have some problems the other day. I was trying to. The VPN was on. Because I run a business as well, and it was on the mobile device, but this on our phone. But trying to install it on this new second-hand Linux setup, I was getting weird things where it wouldn't open the website. Well, oddly, it opened the website if I used 4G on my mobile phone, but if I used the home broadband, it wouldn't. Now, I understand that some providers, and I won't mention who provides my broadband, otherwise I'll have all these scammers ringing up going, can you download this software? Yeah, that's not the accent, you get the gist. You get these people from the other side of the world making out their tech support, and they're clearly not. They're trying to scam you. Anyhow, yeah, it wouldn't let me open them. Now, I did a bit of Googling, and it seems that maybe the home broadband provider was blocking certain websites, like VPN websites, which is odd because they're not illegal. Businesses use them. In fact, people working from home and connected to their business, especially if they're dealing with sensitive data, they will have VPNs. It was just very strange. But there was a workaround. Now the workaround is you go into your router, and like I say, it works on the mobile phone. It's perfectly legal, but my broadband provider decided, no, we're gonna block them. Well, I say block them, they don't actually block them all, because there was an advert on TV the other night for NordVPN, and that works. I don't understand why that's working, but not the one we use with the business. Anyhow, to cut a long story short, the workaround is you change for DNS. DNS being domain name server. So at the moment, by default, the DNS settings were set to connect to my internet service provider, to their servers, and then go via there. So what you do is you change them to Google's servers, which the address is 888888 for the main DNS server. And you do that, go into your router settings. I'll make a video if anyone's interested in how you go into your router settings, but you just change the DNS and where it's pointing to. So it's pointing to Google rather than pointing to Blog's internet broadband service or whoever you use. Internet still works fine, but it's basically removed this block, which doesn't actually make any sense whatsoever. Because, like I say, I can access NordVPN, but I can't access. Well, there's a few. I tried a few. Let's give you an example of a VPN provider that I don't use, but which is also blocked. Proton VPN. If you do some search on it, it's rated as highly good and recommended. But for some reason the page won't open. Well, it wouldn't, but it does now. Because, in fact, I can show you. Let's open another tab. Let's type it in. Proton VPN. Actually, this won't be really a fair test because I've still got the other VPN connected, which would let me access it anyhow. But if I didn't have a VPN switched on, it was blocking me, which was a bit of an issue because, like I say, if there was a VPN on your system, you could access the blocked VPN. But as I didn't have one, I couldn't get a VPN. If that makes any sense. But the workaround is to switch your DNS settings, your domain name server, to Google servers rather than your internet service provider. Totally legal, nothing wrong with it. Supposedly makes your internet work quicker. I don't know if it does. That's something I read. But yeah, seems fine. Yeah, so that's the setup here. It's keyboard found in a skip that was brand new in a box. Same with the mouse, monitor, £10 from a second-hand shop in Hull, probably in about 2013. Yeah, about that. Not even 2012. We 6th generation i5 with 8 gig of RAM, compact PC made by someone in this. Who makes this computer? HP. It's the HP ProDesk. HP ProDesk. Yeah, seems to do the job. Yeah, and then open source software. OBS Studio is our streaming software. My streaming software. Then the operating system is Ubuntu Studio. Again, open source software. So that's the setup I'm using today. Basically, loads of free software and junk. Seems to be working if you're watching this. So connection is timed out. Oh, so I was just looking at live streaming. What's that mean? Connection is timed out. It must be on a bit of a delay here, so it's not as live as I was thinking. Oh, I'm still nattering on. I can see myself. There we go. Right, okay. So let's try OBS Studio again. What is going on? No, it doesn't like that. I don't know why. Okay, so but normally you download OBS Studio and it's free and it's open source. What I was talking about earlier, because I made a video. I made a video basically about radio communications equipment, starting off talking about. I mean, I wish it actually come out because it was quite. If I would say it myself, I was quite pleased with it. I picked up an old piece of radio communications equipment from 1973 that I got from somewhere, and I talked about that. I talked about technological change from the old analog radio equipment. Let's just show you. Hang on a minute. Let's leave the cereal bowl out of the way. I've just had a bowl of cereal. Right. Right, now I'm going to turn the just going to adjust OBS Studio so I can actually see what I'm doing here. Let's get the screen a bit bigger. I don't need that anymore. That's better. Right. Turn Okay, so this fine piece of equipment, so this webcam's weird, it's what you get for £25, everything seems on weird angles, like right. I can move me to rearrange this. I'm having a bit of a sort out in this room, hence putting this computer in here, and it's hang on. That doesn't sound good. Right, plugs and wires everywhere at the moment. Right, that's better. So it's a Pi Olympic. Right, this was made in, these started being produced in 1973. I only know that because I looked up online and there's something called the Pi Museum or something. I don't remember it. Right, so a Pi Olympic is a two-way radio. Now, hopefully this is going to be as good as it was earlier. It was brilliant earlier. Yeah, I was really pleased with myself. What, this is a great live stream. Really getting into this, then realised I hadn't actually hadn't sent it due to not downloading a new streaming key. Right, so a Pi Olympic, a two-way radio. Now, this will have a microphone plugged into it, which would plug into there. You'd also connect an antenna into that, and your power, these wires here. Now, they're built in Cambridge, England, so you've got, what have we got here? You've got some different controls. You've got your on, off, it's sticky, that's stuck, but there we go. It is like 50 odd years old. This is quite cool because you can turn that, then we can see that when you turn the volume, a little red piece there goes up and down. So that's your volume, and that, no, wrong way, that is your channels. So you can flick that to different channels. There's 12 channels in here, or at least there's potential for 12 channels. And lastly, this thing which is just squelch. Basically, if you're listening to the channel, you'd hear a load of hissing noises, and it basically cuts that out until such time that someone transmits. So that's adjustable. Now, these things are still in use today. Not like this though. But before mobile phones existed, if you were a business, you know, a taxi driver, police, well, police aren't business, but you needed to communicate to your workers. You could use something like this. So you'd have this installed in a vehicle with an antenna on the top and a microphone, and you could talk, transmit to maybe your headquarters, and then they can talk back to you. Because before, well, in the UK I think it was 1984 or 85 that Vodafone introduced mobile phone service into the UK. I think the British Telecom did as well. I forget what they were called, Cellnet I think they were called as well. There was two services, but it wasn't, you know, this is how businesses would communicate, because otherwise, once people are out in the vans and you need to suddenly change the plan, you can't just phone them up. Yeah, because they're out and about. There's phone boxes, but you know, if you're out and about working in a van, your workers aren't going to be near a phone box, so they would use these to communicate. They're still in use today, and they're still in use because mobile phones tend to be less durable, and also it's harder to restrict what your workers do with the phones. Who they're calling on? Are they looking at TikTok rather than working? So two-way radio equipment like it's mobile here, or this handheld equipment, are still very much in use, and they're modern ones. But yeah, these are pretty old technology. These are analog, and they use things called crystals. Now crystals are little piezoelectric devices which, well, I think someone might be at the door, hang on a sec. I think we're all right. Now, crystals, or piezoelectric devices, they're a component which would have, especially made, depending on what frequency, radio frequency you wanted, and you'd have a transmit crystal and a receive crystal. So they'll go inside the radio, and it's what determines what frequency your radio operates on. Now, modern radios, starting, well, probably the last 30 years at least, use electronic circuits, phase lock loops, and modern electronics to do the same thing. And they've become more sophisticated. So these days, you literally plug your two-way radio equipment into a computer via an interface lead, bring up the software, and you can change all the parameters to what you want. You can change the frequency, you can allocate people into groups. So if you were running security, a group, and channels for the if you're running an event for the security, it could be on one channel, one group, the catering on another, etc., etc. So it's all linked in. It's all computer programmable. You're programming a computer. A modern radio is a computer, whereas these things, electronics, pure electronics, you change frequencies by ordering the crystals, which are set to a certain frequency. And if you had to calculate, do some calculations, because the crystals don't oscillate on the actual frequency. It's an intermediate frequency which is used within the radios. You have to calculate do the correct maths, otherwise you'll end up with the wrong crystals on the wrong frequency and waste money. So these things, this is antique. It does actually work. It works on amateur radio frequencies. It's actually an AM set, whereas most modern analog two-way radios work on FM. And actually, analog FM has been pretty much phased out now, and it's all digital, mainly the DMR standard for two-way radios. But yeah, this is AM, amplitude modulation, which refers to the way the signal is transmitted. It's quite heavy, this thing, as opposed to FM. Right, I'm just going to put that down. Yeah, I mean, earlier on the original live stream, which wasn't a live stream, I talked more about how when I first started working in radio, before I went to university, we would still get some analog crystal control radios, some old things that some farmers had. They'd come into the workshop and they wanted things doing to them, such as adding CTCSS. Now CTCSS, don't ask me what it stands for, I've forgotten. But how it works, it will only allow you to receive a transmission from someone if the right subaudible tone is being transmitted at the same time. That's what the CTCSS board does. So for instance, 67 Hz or 100 Hz. So it's a subaudible tone that's transmitted, a bit like having the correct key for a lock. And when the correct key is received, the receiving radio will unlock the speaker, to put it simply, and you'll hear the transmission. But if you have the wrong subaudible tone, it won't work and you won't hear them. This is useful if you're on the shared frequency. So if you'd apply to Ofcom for a radio frequency and they give you a shared frequency, now without the CTCSS you would hear other people on the frequency, and if you're going to the edge of the geographic area where your license covers, you may get interference from other people. So CTCSS was good, but old radios like that didn't have it, so we'd have to install them, get the circuit diagram out and work out. You could buy an aftermarket CTCSS board and physically fit them and solder them into the radios to give it CTCSS. Fortunately, well, I say fortunately, it was quite fun. You could probably charge more, to be honest, for the time, because modern radios, they're more like computers. You program them. There's no taking the backs off it, and unless they're broken, there's no taking the backs off them and soldering them and configuring them. I mean, some of the early radios that didn't use crystals, that used what's called phase-lock loops, they were kind of a hybrid. It didn't need crystals, but you had to solder over links, take the backs off them, and solder links to determine the frequency. The old Tate 500 series were like that, and again you had to do some maths and calculate what you were doing to connect the right jumpers to get the thing to work. Whereas now it's a lot easier. You could argue less skillful, more plug and play. Plug and play, is that the right word? But there's less electronics in it these days. Saying that, there's still a lot of electronics if you're configuring things like repeaters. Repeaters are devices that receive a weak signal and then boost it up instantaneously to a stronger signal, therefore increasing the range of your radio equipment, your signal coverage range, and also allowing signals to pass over things like hills, because the radio signals won't go through hills, but if you put a repeater on top, it receives it and retransmits it, so you can pick it up from both sides of the hill. Configuring those is a bit more involved. I set one up during lockdown for a farmer, which was really cool, because handheld equipment which you can legally use in the UK in your vehicle when you're driving, unlike mobile phones. It linked to a repeater, giving him wide area coverage, so he could talk to his workers within the 15-mile radius. In fact, well, that's what I designed the system for, because you have to submit the technical requirements to Ofcom with the regulator, so that they will grant you the license. But yeah, it's a bit more involved, and especially if you don't want to link the repeaters to other repeaters, which is possible. You can do it via the internet these days. It's the easiest way. So you get into computer networking. So it's different. There's less soldering iron, more computer programming involved in radio communications these days. Right, what have we got at the back here? So this thing up here, this is it's a similar age to the Pi equipment. It's probably for early 70s, maybe 73, 74. It's an amateur radio HF transceiver. It's a Trio TS520 sideband transceiver. Right. Oops, on there. It's a bit quiet at the moment. What's on it anyway? I've got two of these, and I think this one isn't quite sensitive. Right, so there you go. That's old amateur radio transceiver. Now, that's my nose itching so much. That was from probably 73, 74, and works on the frequencies I showed you there. The first frequency band that was on was 14 megahertz, which is 20 meters. Now, what I mean by 20 meters is, so the frequency is 14 megahertz and the wavelength is 20 meters. Now, if we run 28 megahertz, the wavelength would be 10 meters. So you see, there's an inverse relationship between wavelength and frequency. So I can't believe the camera can see me because yeah, it's a very strange webcam this. I think it's pointed off at an angle. So the higher the frequency, the shorter the wavelength. That's why if you had, so imagine you had imagine a taxi. Now the antenna is probably, you might see them, will have a short whip antenna, which is like just a metal rod. Might be about, let's see, say about 30 centimeters long. Now that is a quarter wave. That means the length of the antenna is a quarter of the wavelength. So if it's a 30 centimeter long antenna and it's a quarter wave, if we times it by 4, it will give us a full wavelength. So what do we say, 30 centimeters. So the 120. That wouldn't be a taxi antenna. But if you did take that as an example, 30 centimeters times it by 4, you get 120. Hang on, I'm confusing myself here. Right, good job this isn't live. What I was trying to say then, so the longer, higher the frequency, shorter the wavelength gets. Lower the frequency, longer the wavelength gets. That's why 28 megahertz, the wavelength will be roughly 10 meters, whereas for 14 megahertz, the wavelength is 20 meters. So you see the difference, see the relationship. The reason I started talking about antennas and quarter waves is because antennas, so whip antennas, are often on vehicles, are often quarter waves, and the length of it is a quarter of the frequency, the wavelength at that frequency that it's physically cut to work on. When I say physically cut, I'm talking about a thing called resonant frequency. Now resonant frequency is important because you want your antenna to resonate. Now the reason you want your antenna to resonate is because it's most efficient when it's resonating on that frequency. So it needs to be cut to the correct frequency that you're transmitting on. Receive isn't so important, so you could cut it for your transmit frequency. So if your transmit frequency was 100 let's go for 200 megahertz. If your transmit frequency is 200 megahertz and it's a quarter wave, it's going to be 50 centimeters long, your antenna. So because it's a quarter. My brain's going a bit up. This first, right. Yeah, I need a cup of tea. Like I said, I must have been talking for the first one I did what, nearly an hour streaming, and it was really good. And now my brain's just fading, and Yeah, I was thinking that's brilliant. That's really good live, and I hadn't downloaded a new stream key and it wasn't working. I forgot you had to do that. I just hit start streaming on OBS Studio and off it went. Right, so let's do something that involves maths. Right, so these radios here, modern radios. Now, most modern radios now are digital. They use a digital transmission standard. Now, like I suppose this in terms of phones, you've got Apple and you've got Android. Most there's a couple of main standards for digital radios. There's DPMR and DMR. The one that's most popular, a bit like Android, where lots of manufacturers use. That's not a great example because there are more than one manufacturer that make DPMR. Let's talk about video recorders for those of you old enough. Video cassette recorders, you had a VHS and a Betamax, and the VHS eventually won. More manufacturers started using that standard. It's the same with two-way radios. Most manufacturers now use DMR rather than other standards like DPMR. So DMR. So, for example, this right. This is an Intel DMR radio, UHF. Now, I set up a system for a farmer which used Intel radios and Hytera repeater, and it worked fine because they're of the same standard. I mean, like Android, they do, different manufacturers do sometimes tweak the standard, but basically they're compatible. So you could transmit to the repeater using an Intel, and the repeater would work, it would receive it and work fine because it's all using the DMR standard. So if you're looking for two-way radios, digital ones, you're probably going to go for DMR. It's yeah, I'd say it's the most popular standards for them. These things you can do a lot more with modern two-way radios than you could do with the old one, or a lot easier. And like I say, you can link them to repeaters. But the repeaters can be linked to the internet. You could talk on one of these. You go, yeah, Bob, we need some more widgets sending over. Now, Steve could be talking, saying that. Steve could be in London. Bob could be in New York at a manufacturing plant. But you're talking instantly by pressing a button and you're using two-way radio. So you see, they've evolved. Some people think, well, do people still use two-way radios? Yes, they do, because you can press a button and talk instantly. And now these days there's no barrier to geography, to coverage. You can literally have a setup. Think, oh well, I'll ask Bob in New York to send something over, and you could be in London. You can also link to the phone system, to VoIP phone systems, and make calls, and they can call you. So the office could pick up the phone, call through to your two-way radio. Marvellous. Got rugged equipment for your workers, but it could be linked to your office phone. Well, if you like, mobile phone if you like, there's a way of doing that. Right, so that's some two-way radio. Got up here, that is an analog UHF. This whole thing is analog. VHF at about 70 megahertz. These are old radios are converted for amateur radio use. A lot of this stuff, well, it's a mixture. Some of it is amateur radio and some of it is commercial modern two-way radios, such as these Intel and his Hytera. That's it really. What I talked about earlier in the best stream, the one I did earlier before I'm actually done in now. I started talking about other things, like tech things I could find around the room, but I'm really like brains going. I started talking about comparison of magnetic hard drives compared with SSDs, solid state drives. Now, I teach part-time, and the students have been looking at this as part of the curriculum. So we're talking about the advantages and disadvantages of magnetic hard drives like this and solid state drives. I'm almost too tired to do it at the moment. Basically, these, if you had a terabyte one of these compared to a terabyte SSD, these are generally cheaper. Disadvantages: these are less mechanically strong. They've got mechanical moving parts, whereas an SSD doesn't have any moving parts, so they're more fragile. And thirdly, these as a mechanical, and there's a platter which spins round, driven by a motor, and a read head. That takes time. So reading and writing to them is slower on these than an SSD, which is purely electronic. So yeah, I think I'm going to stop this. I don't actually. Oh, we are still streaming. How long have we been streaming for now? No idea. Yeah, I really liked my original stream this morning, but it didn't come out. So I've done 2 now, so I've been talking for about an hour and a half. And I think I'm going to end it soon. Right, nothing else interesting on the back here. Oh, this thing is a LoRaWAN gateway. The antenna shouldn't be doing that. Now, I built that probably about 2017. A LoRaWAN gateway is a type of narrowband IoT device, IoT being short for Internet of Things, and you can use it for carrying out environmental sensing. So for instance, you could have what's called a node, which is the transmitter bit, linked to a sensor monitoring a water tank. And that's sending data to the gateway, and that's then connecting to the internet. Now that particular one, I say I built it myself. The computer part is running a Raspberry Pi inside, which is controlling the radio communications circuitry. I'll show you that at some point, but not now. Yeah, what else we've got? An old railway lamp that I bought in Wales at an antique shop for no particular reason. I just like the look of it. And that poster on the back wall that you can't really see is a poster from the Nikola Tesla Museum in, where is it from? Serbia or somewhere. Belgrade, yes, Serbia. Right. Which I haven't actually been to be fair. I got off the internet, but I'd like to go because Nikola Tesla was a genius. You get in schools, you get posters up. Edison, I mean, fair play to Edison, but he had a whole team behind him. Tesla, he's a bit, I suppose you could call him a bit more of a rebel. He was not mainstream. He was a genius. When I say Tesla, I'm not talking about the car company. They probably got the name inspired by Nikola Tesla. And he, alternating current, for instance, the electricity coming out your plug. Nikola Tesla invented that. Induction motors, which power most factories. Nikola Tesla. A system he designed which could provide free electricity to the world by transmitting it electrically. Well, that kind of there's a bit of conspiracy theory about that, what happened to that, but he basically came up with a system. I can see why vested interest or people that were making money from selling electricity wouldn't be too impressed with the idea of free electricity. But yeah, Nikola Tesla, worth checking out. Just like, yeah, he's just a genius. Anyhow, yeah, that's a bit about radio communications and a bit about streaming using junk, basically. Apart from, like I say, apart from this cheap webcam, this whole streaming thing is done for free using second-hand equipment and free open source software. I don't normally do it this way. I've normally got proper setup with a 4K monitor, the 4K webcam, fast laptop that's been upgraded to the max, gigabit internet. I've got, yeah, everything's flying. But it's a bit more fun this, using a load, like a keyboard I found in the Skip that was brand new mouse again from the Skip, computer converted to run open source Ubuntu Studio, second hand off eBay. Monitor was a tenner about 12 years ago from a second hand shop. It's a flat panel one, but an early one. And yeah, you don't need to spend a fortune. It's more sustainable, I suppose. You could say you can run well, you can run a business. When I first set one up in, well, the current one in 2016, I was running everything off a computer I got out of a Skip and put a few upgraded components on it, second-hand components which I got off eBay. It still runs now. It's years old. It still runs fine. We throw too much away in this society, if you ask me. I know people like new shiny things, and I'm trying not to convince myself to replace this monitor that I've had 12 years, which was second hand, with a new one. I was thinking, should I buy a bigger monitor? And I'm toying with the idea. I've been looking last night. As I say, I've got a 4K monitor in the other room with all the decent equipment, but I don't know. Do I really need a new monitor? This one works. Would be nice, but we'll see. But what I'm just trying to say is you don't need to spend a vast amount of money these days, because people just throw things I don't know. Which brings me on to my TED talk. No, it just reminded me actually, there was two versions of my TED talk. There was the stand-up one. There's a few technical issues with that, which isn't the one on the internet, and there was the interview one. The interview one, yeah, check it out if you want. Just type Craig Miles TEDx, it'll turn up on YouTube. Was me being interviewed. I mentioned, well, the talk was about, there's two, right, at the moment, according to the International Telecommunications Union, which is part of the UN, there's 2.6 billion people, which is roughly a third of the planet, that don't have the internet. There's also, let's get this right, the latest UNESCO figures, estimates, are 272 million children that don't have a school to attend. So the gist of my talk was, why can't we bring online education using the latest in low Earth orbit satellites? Now, low Earth orbit satellites are less than 2,000 kilometers up in the above the Earth. Lots of them connected. I mean, the example of low Earth orbit satellites are Starlink. That's the best well known. But the new technology, which was so cutting edge, it was barely proven when I did the TEDx talk. Fortunately, in between me applying for it and getting accepted, a trial was successful. So I could, yeah, it works. Because it would looked a bit silly if I'd gone, yes, this technology exists now, and it hadn't worked. Well, it did. So that was back in 2023. But it's coming on stream now. There's been a few delays for sort of mainly due to licensing and getting countries to approve its use, but also some technical issues. But now you've got the ability to be able to connect to a standard mobile phone from a satellite. Now the idea is, e-waste is becoming a big problem in this world, and mobile phone use, whilst in countries like the UK, mobile phone recycling, whilst in countries such as the UK, I think it's at 57%, it's reasonable. In countries like India, it's probably about 1%. There's a lot of products, mobile phones, and also computers not being recycled. So the idea was, we use recycled mobile phones and possibly recycled computers to provide education to those that haven't got it. So the mobile phones connect directly to the satellite, therefore we provide e-learning to that 272 million children that don't have a school to attend. We provide the mobile phones, cell phones, whatever you want to call them, for free. Could we refurbish them? And that is how you achieve education for all. Education for all is an ambition of the UN, United Nations. In 2015 they set 17 SDG goals. Now SDG stands for Sustainable Development Goals. Now the target date for completion is 2030. So not long now until 2030. A lot is being done, such as this Project Giga, which is aiming by 2030 to provide internet to every school in the world. Now they're mapping using satellite imagery where the actual schools are, because we don't actually know how many schools there are in the world. But what about the students that don't have a school to attend? The 272 million estimated by UNESCO. So this is where recycled mobile phones connecting directly to low Earth orbit satellites, direct to cell, direct to device, direct to handset, whatever you want to call it, providing e-learning. Why does this bother me? It bothers me, I think, because it bothers me for a number of reasons, and even to my critics, I can see benefits. Right, first of all, why does it bother me? Well, I didn't particularly like school, which is kind of odd, because I'm a teacher, and you ask a lot of teachers, they'll probably say off the record, but yeah, there's a lot about education I don't like too. But it's like any job, you go with the rules of the school, and the rules of the school have been set higher up, by the local authority or the government. But alright, so going back, I didn't particularly always enjoy school, but I got to go, didn't I? It was better than the alternative. So what's the alternative, Craig? Right, imagine that you're in some part of the world with no school, no education. As soon as you're able to, you're forced to work. Or you're married off, you're a girl and you're married off really young to some guy that's twice your age, maybe even more. And the family kind of hasn't really got any option because they've been offered some sort of, they know it will give their daughter a better life. Yeah, I mean, it sounds terrible, but this apparently does happen. So, child marriage, or children working in bad conditions. I mean, I just think, I've got a son myself, he's a teenager now. I wouldn't want him to be working in terrible conditions, digging out lithium or something in a mine in some place, which does happen. Which is, yeah, I won't start talking about lithium batteries and all that, EVs and all that stuff. But there's a whole other area about some stuff that, as well as the legal mining operations, the illegal part. But the point is, I'm lucky. I didn't think when I was at school, I thought, God, I hate this. I really didn't like it. But I'm lucky that I got the chance. I'm lucky that I went into somewhere safe. I got fed. Occasionally learnt something. it was a chance. Whether you choose to take the chance to use it to your advantage, or you don't, you've got the choice. But if you don't get the choice, that just doesn't seem right to me. That's why I think that the UN goal is called SDG 4, Sustainable Development Goal 4. So it's one of 17 goals, and its aim by 2030 is to provide quality education for all, basically. So not just children, but adults, but children are quite a big focus of it. So providing education for all. What was I going to say? I've forgotten. But I think everyone should have a chance. I mean, there's plenty of people out in the world who go. In fact, the first time I mentioned it, I got this comment. It was, yeah, but why should we care about the foreigners or whatever? Or we should care about our own kids first. Well, yeah, I agree. I agree that we should look after people in this country as well. That's what I would agree with. But supposing you're one of these people that wants to send all the foreigners home or whatever. Okay. And you don't like immigration. That seems to be quite a popular viewpoint at the moment, certainly in the UK. If you had the opportunity, if everyone had an opportunity to gain an education and a better life, it might, I'm not saying it will, it might improve the country they're in, originally from. Now obviously there's things like wars and the rest of it, but if more of the world was thriving and there wasn't so much we're the rich guys, we're the poor guys, if everyone had the chance. Now I know everything's not going to be equal, but if everyone had a decent standard of education, a decent standard of living, opportunities, this is going to benefit even the people that don't like immigration, surely, because they're not going to need to come to your country. I mean, to be honest, I don't really care too much, you know. I'm quite easygoing, but I kind of see why. I kind of understand the argument about housing or whatever. The people think, well, they might be taking away housing, but then again, the population that's already here is getting smaller, so swings and roundabouts, isn't it? So we'll talk about depopulation on the one hand, and then some people are moaning immigration. Basically, what I'm trying to say is, if you've got more of a level playing field where people have got opportunities, possibly in their home country, and they're able to trade, they might not want to move about so much, because they can. The internet's brilliant. The internet is great, but like I said, 2.6 billion people who can't access online education, can't access business opportunities, because they haven't got the internet or haven't got regular access to it. But if they did, it benefits us. We can sell to them, they can sell to us, we can find out about, learn stuff about them, they can learn from us. I mean, think of all that untapped potential and human resources. I don't like the name human resources, people aren't really resources, but you know, there might be some genius computer scientist in a remote village in Africa with no internet access. But if we got them internet access, they could contribute. They could be online. They could be the next Louis Pasteur or Nikola Tesla or I'm trying to think of I can see her in my head. Who's that famous female scientist? I can see her in my head. I can't remember what her name was. But you get my gist. There's so many people offline that could be online and contributing and making this world a better place, making it better for everyone. But they need to be online. We don't have, what can I say? AI is becoming a big thing in our lives, in countries where we're connected to the internet, amongst people that are connected to the internet, which is great. I know some people don't like AI, but it's a fact and it's here. But if you're not even connected to the internet, you're getting left further and further behind. So these new technologies are making our lives, though some people would argue that it is making their lives better, but it's making our lives different. We're progressing, I suppose. We're getting new skills. 5 years ago, if someone said, can you use ChatGPT or DeepSeek or Claude or whatever you want, whatever AI you use, you would have gone, no, what are you talking about? I use Google. But things are moving on. But if you've never even heard of Google or never used a smartphone, and even if the internet itself is an alien concept, just nick that piece out to start my TEDx talk, you get left further and further behind, and that can't be good for the world. I just don't think it is. I think we need to use what we've got. We've got plenty of old tech lying around. We've got plenty of old computers lying about. That's not the issue. We can provide equipment for everyone. The only possible potential issue is paying the satellite owners a fee to be able to connect. And there's various ways we don't have to use satellite, even though that's what the TEDx talk was about. That is the best way for remote communities to access the internet. If there was no cell phone coverage, no mobile broadband nearby, there were a few different options we could use. Because the reason not everyone's connected to the internet, or one of the reasons, apart from it being expensive for them, is lack of infrastructure. You're not going to put in a cell tower and all the communication links, the cell tower being the device that communicates with your mobile phone, with your cell phone. You're not going to put that in to a village or a location where there's no one there to pay for it. Because what's the point? You're a business. You're in the business to make money, not provide a charity. We can connect directly to smartphones now. We connect directly to satellite. We connect to satellite. So we've got the technology sorted, and there's other options which we can use as and when necessary. What we need is the funding model. Now, I have talked about the funding model before. I think I even talked about it in the TEDx talk. I did. We could do it at a UN level, at a charity level. There are various ways you can fund this. If we can fund a goat in Africa, and you've seen these things where you can charity fund a goat in Africa. If we can do that, we can fund mobile phone access. That is why the internet for everyone, education for all, Sustainable Development Goal 4, I believe is achievable. We just need to do it. Time is running out. People are getting left further and further behind, especially with the advent of AI. They need the internet. They need to be connected. It's good for them, and it's good for us. Right. Okay, so I think I'm going to stop streaming now. I'm going to go to lunch. Okay, let me know what you think.